Alright, let's take a look at another method to solve systems of equations. This one is called the elimination method. The reason it's called the elimination method is because you're going to line the equations up in such a way that you can eliminate one of the variables. So first let's build our understanding on the idea of the elimination method. So it's completely based on the golden rule. Whatever you do to one side, you have to do to the other. But we're going to kind of apply that in a bit of a new way. So suppose you start off with an equation $10 equals $10. I could add $3 to both sides, and I think you would agree that I followed the golden rule, plus $3. And then I would have, ignore that, plus 3. I'd have $13 equals $13. So bear with me, I know that's maybe not the most exciting thing, but the next step is the critical part. I know that $1 is equal to 4, I'll put Q for quarters. Okay, so if I know that $1 is equal to 4 quarters, I could add, say for example, plus $2 on this side, and what would I have to add over here? I would have to add 8 quarters, because if $1 is 4 quarters, then $2, is 8 quarters. So would you agree that I've followed the golden rule? I've added $2 on this side, and I've added 8 quarters on this side. Now, because that $2 is exactly equal to 8 quarters, I have followed the golden rule, and this is exactly the same thing, right? $15 is equal to $13 plus 8 quarters. So even though it's written differently and it looks differently, I've done the same thing to both sides. So we're going to use this principle to combine two equations together in such a way that some variables will cancel out. So we're following the golden rule, but it looks a little different than you're used to. So we're going to get two equations, and we're going to add the entire left side and the entire right side together so that one of the variables will cancel out. This is what it's going to look like. Say we have an equation 3x plus 2y equals 5, and another equation, I don't know, 6x minus 2y equals 4. So we have a system of two equations like this. Now, I know that 6x minus 2y is exactly equal to 4. So here's what I'm going to do. I'm going to take this first equation, and I'm going to add 4 to the right-hand side. Okay, then I get 9. On the left-hand side, if I added 4 on the right-hand side, I also need to do plus 4 on the left-hand side. But instead of adding 4 on this side, 4 is exactly equal to 6x minus 2y. So instead of adding 4 on this side, I'm going to add 6x minus 2y on this side. So this is how much I'm adding on the left, and this is how much I'm adding on the right. Oh, my dog's going crazy. But you can see, because 4 is equal to this quantity here, the amount that I'm adding on each side is actually equivalent, even though it looks different. And the reason this is so useful is because now when we add the left-hand side, we've got 3x plus 2y plus 6x minus 2y. The 3x plus the 6x will combine and give me 9x, but the 2y plus a negative 2y cancels out, and I just have 9x equals 9, and therefore x equals 1. So it's a way to very, very quickly cancel out one of your two variables. Now, you can see that the critical component to make this work was that I had a positive 2y here and a negative 2y here. And so when I add the two equations together, I add the left-hand side to the left-hand side and the right-hand side to the right-hand side. I can do that because I'm following the golden rule, and when I do that, one of the variables cancels out. If adding the two equations together did not cancel out one of your variables, then this is not a good method to use and you might want to try something else. But if you get two of these variables to match up, so I like to call this matching up. So that means you have a positive and a negative value that will cancel each other out when you add the two equations together. If you have either the x variables matching up or the y variables matching up, then this elimination method, it's also often called the addition method because you're adding two equations together. If it happens so that one of them will cancel out, then this is a fantastic way to do it. Okay, let's look at some more examples. Let's try 3x minus y equals 2 and negative 3x plus 2y equals 1. Okay, so you can see right away, you compare your x values. These match up. We've got a positive 3x here and a negative 3x here. These don't match up, but that's okay because the x's are what's going to cancel. So I add the two equations together. Here I've got 2 plus 1, which is 3. So I add the left-hand side. I added 1 on this side, and I'm going to add all this stuff over here because it's equivalent to adding 1. Over here, the 3x and the negative 3x cancel out, and I have a negative y plus 2y. So negative 1y plus 2y just equals y. And so I'm already done. In one step, I've already got y equals 3. Okay, so we're not done yet, and in the previous example, let me go back to it real quick. I was not actually done when I got x equals 1, because remember, when you're solving a system of equations, you're trying to find the entire solution point. So you'd need to plug x equals 1 back into these equations and find that y value. Let me do that real quickly. You've got 3x, which is 3 times 1, so just 3, plus 2y equals 5. So I'm going to quickly subtract 3 from both sides, which gives me 2y equals 2, and that gives me that y equals 1. Okay, and we can check that by making sure that this works in the second equation. 6x minus 2y, 6x is 6, minus 2y, that's minus 2, so 6 minus 2 is 4, so it worked. Okay, I wanted to go back and just show that to find the full solution, you really do need to find both x and y. Okay, now let's catch up to where we were. Sorry for that mistake. Now, we've canceled out the x's, and we've gotten that y is negative 3. So now we need to find out the x value. We can plug this back in. Now, it doesn't actually matter whether you plug it back into the first or the second, and I encourage you to plug it into both and make sure that you get the same answer. That's how you can check it and make sure it's right. So here we have 3x minus 3, because I'm plugging in 3 for y, equals 2. To solve this, I add 3 to both sides. I get 3x equals 5, and therefore x equals 5/3. Okay, let's check that by plugging it into the other side. Negative 3 times x, we got 5/3, plus 2y, plus 2y is 3. So I'm really just plugging this y value in for y, and this x value in for x. And this is supposed to equal 1. So this 3 cancels with this 3, and I have negative 5 plus 2 times 3 is 6, equals 1. Negative 5 plus 6 is 1. 1 equals 1. So I've checked it and I've confirmed that my answer is correct. Okay, let's do another example. Let's try one where they don't actually match up to start with. So suppose you have, for example, 2x minus y equals 5, and I don't know, 3x plus 4y equals 10. So when you look at this, you can see the x's don't match up, and the y's don't match up. So what do? Well, one option is you could go back and use a different method, like the substitution method. Maybe you want to solve this equation for y, and then plug it in. But you can still use substitution method. You just have to take a first step to get them to match up. So you want these two numbers to be the same number but opposite sign, or these two numbers to be the same number but opposite sign. So a 2 and a 3, it's not that easy to make a 2 into a 3 using multiplication. But we could make a negative 1y into a negative 4y very easily by multiplying this top equation by 4. Okay, so if I multiply the entire top equation by 4, I get 8x minus 4y equals 20. And so that's an equivalent expression as this guy, because the left-hand side got 4 times bigger, and the right-hand side got 4 times bigger. And over here I can rewrite the one that I had just for clarity. And now you can see, by doing this first step of multiplying everything in the first equation by 4, the y values match up, and when I add them together, these will cancel out perfectly, leaving me with 11x equals 30, and x therefore equals 30 over 11. Okay, just to shorten this video a little bit and not waste any of your time, I'm not going to plug this x back in, but remember, to get the y value, you'd need to plug this equation, or this x value, back into here, or back into here. You can use either this equation, or you can even use the original equation, that might even be better, or back into here. So you want to plug it into any of these, and then solve for the y value. And then to double check your answer, make sure it works properly in both, so that you get one point that works in both equations. Okay, so now you've learned 3 different methods. One is graphing, one is substitution, and one is elimination. Typically the problems will either say use any method of your choice, or they'll tell you exactly which method to choose, and then make sure you follow that along. But remember, on a test or quiz, if you're not comfortable with one of the methods, you can always double check it using a different method.